Hi, my name is Jonathan, and this is my ENME 351 final project. Here's the robot doing a few scrambles and solves of the cube. You'll have to trust me that the solve isn't just reversing the scramble. Like I previously discussed, it uses Kosiemba's algorithm and the known state of the cube, so you can solve it from any point if you input the cube state manually. I am working on functionality so you can scan the different sides with a phone webcam and OpenCV, but that's still pretty much a work in progress. So for now, the robot has to scramble the cube itself. While the robot solves the cube, I guess I can go into some of the more technical or hardware aspects of it. It's actuated by 4 NEMA 17 stepper motors, each of them driven by a TB6600 driver off a 12-volt supply. That's an Arduino Mega. The whole thing was printed on a Prusa Mark III, and the left motor, importantly, is mounted on some hardened steel axles and linear bearings in order to let it slide freely and not always be coupled to the cube, so you can easily insert and remove the cube. The little flipper on the front essentially stops the center of the cube from rotating when you want to make individual right or left moves, and the claw in the back does the big up, down, front, and back moves. Alright, so I'll do my best to explain how the code for this project works. I can't go into detail for like each source code because that would take way more than 5 minutes. But essentially, the Python scripts are the brain of the operation. So control.py receives a cube state via serial from processing and returns, using Kosiemba's algorithm, a string of solve moves. FaceColor.py receives a scan request and scans that side of the cube. It's not quite working yet, but we're getting there. So right now the cube has to scramble itself. Within processing is contained the current state of the cube in the form of 6 side arrays. Those arrays can be manipulated to perform moves, so processing can virtually scramble the cube and also virtually solve the cube using Python. The Arduino side of things, as denoted by the dunce cap, is stupid. All it knows how to do is basically actuate the moves it was given by processing. So when you click processing or scramble on the processing GUI, it sends a list of moves generated in processing to the Arduino, and it performs them. Same with solve. And yeah, that's pretty much it. The Arduino and processing communicate back and forth. Basically, every time the Arduino performs a move, it sends a confirmation character back to processing, and the processing updates its GUI to the next frame so that the virtual cube maintains the same solve speed as the actual cube in real life. For my sensor, I used an AS5600 magnetic encoder because I couldn't get IP webcam hooked up to OpenCV to work just quite. So yeah, my sensor was the encoder. Basically how it works is the big claw at the back of the cube is really finicky and needs to be aligned perfectly in order for the mechanism not to jam up. So the 5600 encoder allows for precise calibration of the stepper motor up to, I think, 0.125 degrees, which is way more precise than I need.